What's going on, everybody? Welcome back to my YouTube channel. We have a math question which says find x for which 16 to the x plus 44 to the x is equal to 121 to the x. Well, our first step will be for us to divide through by 16 to the x. So we have 16 to the x. We'll divide by 16 to the x plus we have 44 to the x. We'll divide by 16 to the x. This is equal to 121 to the x. We also divide by 16 to the x. Now notice that 16 to the x divided by 16 to the x, we have 1. So this is 1 plus this we have 44 to the x all over 16 to the x equal to this is 121 to the x all over 16 to the x. Very good. Now we know that from indices, whenever we have a to the m divide by b to the m, as long as the powers are the same, this is equal to a over b to the common power. So we're going to be expressing this and this like this. So we have 1 plus this becomes 44 all over 16 all raised to the common power x. This is equal to, we do the same here. This is 121 all over 16 all raised to the common power x. Very good. Now notice that we can actually break this down. So 4 can divide. So 44 divided by 4 is 11. And then 16 divided by 4 is 4. So this is 1 plus this becomes 11 all over 4 all raised to the x. This is equal to, now notice that 121 is a perfect square, which means it can be written as 11 squared all over, and then 16 is also a perfect square, which means it can be written as 4 squared. Very good. So this is raised to the x. Very good. All right. So we have a common power here again. So we're going to be expressing this the same way. So we have 1 plus, this is 11 over 4 all raised to the x. This is equal to, now expressing in common powers, we have 11 over 4 all raised to the common power of 2. And remember, this is raised to the x. So I'm going to be raising the whole of this to the x. Very good. Now, our next step will be for us to apply the law of indices, which says when I have a to the m and this is raised to the n, this is same as long as the powers multiply, that means it is possible that we switch the positions of the power. So this can be a to the n or raised to the n. That's it. So let's express this like this by switching the positions. So we have 1 plus 11 over 4 all raised to the x. This is equal to, this becomes 11 over 4 all raised to the x. And this is raised to the power of 2. Very good. So you notice that we have an expression like this here. And since we have this kind of expression, we can introduce substitution by saying let 11 all over 4 all raised to the x be equal to y. So that means wherever we see an expression like this, we're going to be substituting y. So this becomes 1 plus, this is y, equal to, this becomes y squared. So y squared. Very good. Our next step will be for us to subtract 1 from both sides. Subtract 1 from both sides. We also subtract y from both sides. So subtract y from both sides. Very good. So we have 1 minus 1 is 0. And y minus y is also 0. So we have 0 on the left hand side. This is equal to, on the right, we have y squared minus y and then minus 1. Very good. Well, an expression like this is same as by flipping the position, y squared minus y minus 1 is equal to 0. So we have a quadratic equation, and we're going to be using the quadratic formula to solve this. So for this, our a is a coefficient of y squared, and that's 1. Our b is a coefficient of y, and that's negative 1. And our c is a constant term, negative 1. Very good. So since we're looking for y is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So now let's substitute this into the quadratic formula. So we have y to be, this is negative b is negative 1, plus or minus the square root of b squared, b is negative 1, so that's negative 1 squared, minus 4 times a is 1, times c is negative 1. Very good. All over 2 times a, so 2 times a. So this simplified into y equal to negative times negative gives you positive. So I'm going to be having a positive 1 plus or minus the square root of negative 1 squared is 1. And then negative 4 times 1 times negative 1 is positive 4. Very good. All over 2 times 1 is 2. So this simplifies into 1 plus or minus the square root of 1 plus 4 is 5 all over 2. Very good. So we have two values of y here, of which one of them is 1 going with a positive plus the square root of 5 all over 2. And the other one is 1. This time go with a negative minus the square root of 5 all over 2. Now notice that this other value of y is negative. So we're going to be rejecting the negative value of y. I'm going to tell you why on the next slide. But this is the value of y that we're going to be accepting. This one we have here. So recall that we introduced substitution that let 11 over 4 all raised to the x be equal to y. So since we're looking for x, what I'm going to do here will be for me to try and make x the subject. And since x is an exponent, I can take the log of both sides in order to bring down the x. So take the log of both sides. So take log of the left hand side, which is 11 over 4 all raised to the x. This is equal to, I'll take the log of the right hand side, which is y. Now I'll apply the law of logarithm, which says when I have the log of a to the n, this is the same as n log e. So let's bring down the x like this. So this becomes x log 11 over 4. Very good. And this is equal to log y. Now in order for us to get the value of x, we have to divide both sides by the coefficient, which is log 11 over 4. So on the left, I have x log 11 over 4. I'll divide this by log 11 over 4. This is equal to, on the right, I have log y, and I'll divide this by log 11 all over 4. Now notice that this can cancel off, leaving behind x to be equal to the log of y all over log 11 all over 4. Well, I know I'm going to be substituting the value of y, but before I do that, I should be applying the law of logarithm, which says when I have the log of m divided by the log of n, this is actually the change of base law. This is equal to log m base n. So that means this expression can be written as x, which is the value of x, is equal to log y, now base 11 over 4. You see that? That's it. So now bringing out the value of y, so this is log y. What's the value of y we are using? We're using 1 plus the square root of 5 all over 2. So that's the value of y we're using. And now base 11 over 4. And now let me tell you the reason why we're not using the other value of y. The other value of y is negative, and it is impossible for us to have a negative log. So we're only focused on the positive. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.